So just to remind everyone, we are trying to finalize the requirement. It is based on the requirements published in the existing -HA document. So our goal is to review all of them, add things that were maybe implied and put them explicitly into the list. And so that we won't have anything that is that won't be clear before we move on to the next phase, which is defining all the flows and all the scenarios by which HA should operate. So we stopped at, I think, no complicated hashing logic in switches to ensure packets land on the right appliance. So if you have any questions to the previous one about the downtime, ability to resume connections, the fact that the full flow table should be replicated to the peers, we need to be able to handle link flapping and asymmetrical flows. And this is, by the way, what we wanted Michael for. So this still to be reviewed. Cases when we need to support asymmetrical flows when so the reasoning behind this.
What is your definition of asymmetrical flow?
Yeah, so this is, let me remind you from our last discussion, we were talking about the case where it is possible when we have flow, we have two directions of the flow, and in one direction packet, it does not look the same way as in the opposite direction. And I'm not talking about swapping source and destination. I'm talking about in one direction it could be encapsulated, in the other one it could be not encapsulated or encapsulated in a different kind of tunnel, resulting in switches hashing them to different appliances, so that one appliance will get the outbound direction, another will get the inbound direction. So we wanted to clarify this point at this meeting. What are the exact scenarios so that we can plan for this to be supported as well.
So I don't think we have many scenarios for asymmetrical flows. So, but there's two things, right? So I don't believe we have many scenarios when that packet leaves in one way and arrives in different way. The only kind of scenario like this in case it goes through load balancer, so the internet traffic, because the traffic going to internet goes directly, and the traffic returning back will have first the kind of like outer encap from SLB forwarding appliances to the specific node, but then after this internally it will look the same from this point of view. So that's so not many scenarios like this, mostly for the load balancer scenarios only. And to be honest, the one thing that you mentioned, second bullet from the bottom, when ensure both and inbound and outbound packets transit the same appliance for the given flow, we should not take it as a requirement, because TORs are like normal forwarding appliances. Link will change, the TORs will go into maintenance mode or those kind of stuff, right? So the main reason for the flow replication, which is kind of like a fourth bullet point, to make sure once we create the flow, this flow is kind of immediately replicated. And the main reason for this is that the packet later, as the connection is happening and is already established, right, can come to a different appliance, and this is fully normal. So this ensure we should cross it out, because this will not be happening. Like we don't have, will not be able to have this requirement.
But I think this one is talking about, so we should distinguish the establishing of the connection from connection already established, and the flow is moved to a different appliance. So in case the connection is already established and replicated to another appliance, there is no problem in moving that flow to another appliance. I think the question, so those two can be summarized into a question: do we envision a case where both appliances take part in establishing of the connection?
So I would take, considering that we are designing system for like high CPS, right? So high connection per second, and we want to have a guarantee that when the connection is fully established, we'll never lose this flow, right? Somehow this other appliance needs to be in a path during, for example, the SYN exchange, right? Because it cannot be asynchronous replication for every single stuff. And main reason for this is asynchronous replication just doesn't have these guarantees. Like in a way, if only one appliance is participating in SYN-ACK exchange, right, and the other appliance is just receiving packets, something like FYI, this was this, right? If the FYI packet get lost, for example, right, and the primary appliance dies, then the specific flow dies. So I believe that those two appliances should work more kind of like the package, the SYN package should be going through both appliances, like in a way one appliance then forwarding to the second. There should not be like asynchronous replication, because asynchronous consistency like is eventual consistency, and this doesn't guarantee the strong consistency of the flow table and traffic. And you also have to queue that you need to manage with regards to build up, right? Because if you have lots of kind of like asynchronous stuff, right? So either you're relying on something which is like, if you, for example, have only one appliance that's doing basically the SYN-ACK exchange, and as part of this traffic path, it never forwards the packet to the second appliance, only kind of like FYI, let's say UDP packets, which let's say can get lost, right? Then either you are relying on this, that packet can get lost and this flow will never be replicated, right? Which will be bad, right? Or you actually have a kind of like TCP connectivity there, and you'll be retrying those kind of packets, right? So you're relying on having some queue and potentially the queue build up on your forwarding appliances, right? So instead of having queue build up, why not just bounce this packet across two appliances? So it arrives on first appliance, we just bounce it to the second appliance, bounce it back, and kind of forward it out.
So Michael, you should read the document I wrote, because he's saying all the opposite. Because if you send all 6 of those packets to the other appliance, you're going to chew up more than half of all the bandwidth, which is not good either. So if you're going to chew up half the bandwidth just for sending packets as is to the other appliance, you lost half your bandwidth, maybe more, because 5 million connections per second times 6 is 30 million connections per second. That's more than half the bandwidth. So,
that's true. So yeah, we should not transfer all the packets, but we should transfer definitely the final. Let's
so maybe
at least the final
we can
packet,
make an
right?
exception. Yeah, maybe we can make an exception for the SYN because it's so important for the establishment. But quite frankly, we can't do that for all the packets, or we don't really have a viable design. So I do have a paper on this that I wrote, which I could probably share next time. And I think it's going to be some kind of blend of things, but we can't send every packet. We do that today, and it worked great, fine, but it also chewed up more than half of that.
Yeah, not all the packets. Like mostly, I think this should be like the remaining packet that actually establishes the flow, the last packet, right? This one should definitely go there.
So we can debate that in the future. So I want that to be remain kind of open, because I think Excite probably has some ideas. I wrote some ideas down. Probably it's somewhere in between. But we just need to be mindful of, we at all costs don't want to be chewing up all of our bandwidth for replication. So take that as a side note. I think it's worth. We will be probably talking about that for weeks, I'm sure, to get it right. It is like that. That's the hardest thing, to try to balance the bandwidth of replication versus the quality of replication, which we're all concerned with. And I'll share my paper. I'm just trying to finish it up the next time we meet.
Yeah, so I think we can leave this one open, and on the next meetings when we will move to defining the flows, this will be brought up again, and hopefully when we will define how exactly the protocol should operate, we can come back to this requirement and close it. Yep. But at least I think it's a good thing that we know the trade-offs.
Yes, yeah, there's trade-offs.
Yeah, there's definitely trade-offs, and I would say this even gets slightly more complex for SLB packets, because the SLB packets, for example, at some point, if we add nothing, support including NAT pools, but I'm thinking about this much more in the future, but we can also think about this kind of like right now to make sure what we design will support it, right? Because if we add NAT pool support, this means that dynamically the device can select some port for nothing, and this port if the packet comes back, let's say through the other appliance, right? This NAT port needs to be exactly the same to transfer it back. Those kind of stuff. That's why basically at least this initial set of, so I would say initial set of packet with, for example, let's say there is a SYN, right? And the SYN selects some specific port for the transformation of the NAT, right? Because the ports are dynamic, let's say, right? The SYN will select a specific port. So this port should be, most likely this packet needs to be bounced through all the appliances to make sure that all the appliances persist this selection. So whenever some returning packets during this exchange land on the other appliance, the appliance knows how to revert it back to the correct port, right? And then the question, should this first packet be the one who is, which is basically already establishing a flow and doesn't care about the SYN-ACK packet, or do we also want to bounce SYN-ACK packet to make sure we somehow communicate to the other appliance that this flow is actually alive? And not something that was not fully established, for example, right? So, but that's yeah. Yeah.
In my paper, I talk about that because we're going to use we should be using the TCP state machine. It tells you when something is open. It tells you when it's closed, and there's a million ways to close something, but it tells you that. So it's the only foolproof way of knowing I started a connection, but the state machine is telling me I'm closing that connection and going to the listening state. So there's a lot of reasons for that, but if you use the state machine, then you won't have to worry about that. You won't have to be forwarding ACKs and all this stuff because the state machine will tell you when to close it.
Yeah, so Gerald, the state machine, yes, the question here is about basically because the packets will be going through one device, for example, only, let's say, most of the time, right? Or some packets will be going through one and the other. The question is basically how to correlate the state machine state across two devices, for example.
Yep, I discussed that in the paper.
Yeah.
So that'll be for next time. I'll issue the paper. I just need to have another week or so.
So, Gerald, the paper you are mentioning is the patent, or different paper?
No, different paper.
Okay.
Yeah. Okay. So let's move on. Interoperability. So mostly we are talking about. So let's try to understand which interoperability we're talking about. First of all, there is between, I think I have more elaboration on that. Yes, so HA interoperability is required between vendors. The HA packet format and protocol must be public, so we can pretty much work in a matter of plug and play. We don't really care about which appliance is peering with which appliance. So then another one from the Dash document is HA protocol for syncing active flows. So I think this again will be reviewed in more details when Gerald will come forward with his paper. What modes of operation the protocol should support. So especially if we're talking about that we need to be able to bounce the packets for the SYN. If that will be the case, probably this will be the only requirement. But then for updating the flows, there might be different modes. So we should potentially be prepared for more than one mode, and this should be established during the peering session bring up. And this one, I think it's quite important. Also from the document, HA protocol does not need to reliably sync 100 of the flows between the cards. But again, as we talked about this, there will be trade-offs. So even though there is no 100% requirement, I think along with the protocol, we need to define all of the possible ways that the protocol may fail to synchronize a connection. Not only the good cases, but also everything that might go not so well. Yeah, so this is all from the document. Any questions to these four requirements? Maybe someone would want to add something, be more specific.
Yeah, Marian, can I make a comment?
Hi, Chris.
Hi, hey everybody. I don't know if you'll get to this later in here because I mentioned on a previous meeting about observability, and if I'm jumping ahead, let me know. But I'm wondering if we ought to have observability as a requirement. And related to that last bullet there, it does not need to reliably sync 100% of the flows. I think we all agree in principle, but if we don't have some objective way of measuring or having metrics or KPIs, then it just becomes useless, right? We have to have some way of saying, well, how well does it work? How can we compare one implementation to another? So that's probably going to be a work in progress, but we'll need to establish some metrics, right? So that we can say, well, this is good enough, or this isn't good enough. Right?
Yeah, that's true. So we should have a way to measure this. I agree with you, Chris, right? And the last bullet point with regards to does not need to reliably sync 100% of the flows, right? I actually don't want to put it as a requirement. I would like to put it as actually that preferably I would like to be able to, unless there is a bug in algorithm, right? Or we say that some specific flows, because they are, for example, being terminated or not, or during established phase, those kind of stuff, those we include, right? For me, like if there is two devices and then, for example, one device dies and the other device, for example, comes online, right? And for me, like all the flows which the first device has in established mode, right, should be synced to the backup device, because basically if we say that only like some flows randomly with some probability get synced to the other device, right, then we really don't have kind of running HA, right? I'm kind of okay with agreeing that, for example, if the flows is right now being established and it's not fully established, then maybe somehow the reliability is not yet fully there, or the flow is basically dying, those kind of stuff, right? But if the flow is very stable, established, and customer has like ongoing connection to, let's say, storage and downloads it, right, this flow definitely must be synced. So that's why I don't want to put this like fourth bullet point as a requirement to say not.
I agree with you, Mike. I think we could change that requirement to HA protocol as a goal should reliability sync. But the as a goal means obviously there'll always be exceptions. I mean, there just will be. But you can say as a goal should sync 100% of the connections. And then we'll need to measure how well that's achieved, right? And so we might find use cases down the road through observability. So I'm agreeing with Keysight. Through observability, we might find cases that we never thought of that doesn't allow the 100% sync, but it shouldn't be our goal. Our goal should be 100%. We put in observability, we test, and you know, we will improve it over time to meet that goal. As we find, you know, bizarre cases that nobody's thought about.
Yeah,
so I think that's a better way of putting it.
Yeah.
But you have to couple it with, we need to have observability so that we can measure our success in that for 100% sync, right? That's we need to add that. That's what's going to allow us to go and find those use cases. Exception cases.
And the observability will also have to be somewhat standardized too, so that whatever instrumentation we enable, even there'll probably be two types of observability: high fidelity, maybe for testing, and probably lower fidelity, lower resource intensive for live, right? Maybe it's sampled, maybe it's maybe data are coalesced and emitted at a slower rate, something. But you know, we're gonna have to brainstorm that. It's gonna be a fun discussion.
Yeah, I agree. By having in the requirements and not making an afterthought is important.
Thank you.
Okay, so I'd like to return also to, actually, let's keep them as is. So the last point, as Michael already mentioned, there are cases in the future when we will add NAT, maybe some other stuff which will affect how the protocol works. So I think we need to take that into account as well. So that there are two ways to go about it. We could either make the protocol extendable in a way that we will support different formats of the messages, or we can try to incorporate everything into a single message type. Either way we go, everything I think should be documented, so we will not return back to that question, hopefully in the future. Probably there is still something that will be left out, but all of the cases that Michael mentioned and that we can think of that reasonably fit into use cases for Dash, I think they have to be accounted for. So and also defined in the protocol description how it will be used for them. Yeah, so
I think this one can be described as examples, either modes of operation or packet. Like you said, the other way to do it is through in the packets themselves, adding extensibility to the actual messaging. One or the other needs to get done, or actually both. Both can occur simultaneously. Like you can say, this mode of operation, for this mode of operation, you need to have this extensibility of the packet format, and that's true too. But design it in a way that this is possible, because it's going to have to be possible. Like I actually think mode 1 will always be send all the connection packets to the other guy, make that work. That's mode 1. Mode 2 is make that way more efficient. Mode 3 is account for load balancing, for example. But I think the first mode is the simplest mode, easy to test. Would be like the one that's mandatory, because without it you don't have anything. And then the second mode should probably be mandatory, but we'll debate that as we go along and define it.
Yeah, right. Okay. So this is all we have for the requirements. I think there will be still future discussion going, especially with what Gerald has to present. But besides the requirements, I think the next important.
I don't know. Did you ever say in this requirement that like I didn't see it explicitly. I know we've written about it, but that you need to not only be able to fail and the other device take over, but you actually need to be able to resync a device that comes back online or a new device. Either way, you have to do a perfect sync. But I don't know if I saw that in the requirement.
Yeah, that's true.
So it's a resync a new peer or resync the failed appliance once it comes back online, right? It's failed because it did a software upgrade or whatever, but you have to resync it. So that's what we call in the paper perfect sync. You can implement it any way you want. We gave an example, but that has to exist. Otherwise, you'd never be able to come back. You'd just fail over and you're stuck in the failover state. Whereas what you really want to do is resync after the device comes back and the flow should migrate back. So that's part of the requirement.
Yeah, and one additional requirement that I think we should also add in addition to basically resync back, right? To have ability from the control plane to control when we should start advertising back BGP. And basically the scenario here is that even though, for example, let's say there are two pair devices, right? If a device comes back online and resyncs the flows, right? Sometimes we do not want, as soon as the device have all the flow resyncs, to instantly start advertising BGP. And the example scenario here is, for example, let's say there is some big company that we have on the cloud that have some very critical business. Let's say there is Black Friday, right? One device failed over, right? And they notice some like connectivity drop or those kind of stuff, right? And they will tell us that, hey, if you need to service the device back explicitly, those kind of stuff, right? Do this outside of our hours, business hours, right? So in this case, the new device will be brought online, will sync all the flows, right? But we may decide to, for example, control that, hey, start advertising the BGP after we do additional, for example, health checks, right? Which means that the health model on our side is more complicated. It's not only that two devices are in full sync, right? So each device basically should, in my opinion, maybe as requirements to report something like a sync status, right? Whether, for example, device is not paired, or device is, for example, right now starting pairing, device is syncing flows, or the device is in full like stable ready state, and the connection is kind of online between the devices. So only once we receive that the device is full, the device were fully paired back, and then the device fully synchronized all the flows and are ready to kind of like fully take over. Only then, for example, we will check some additional health checks and then issue the command from the control plane saying, okay, you can start advertising BGP and handle the traffic, right? So we need to have a manual control of this on our side through control plane.
And that even the manual control does have an exception that, because that's a valid case, like Walmart, somebody says, no, don't touch it, wait till my hours are over. But during that time, the appliance that's working becomes non-working. Obviously, they would want you to fail over. So the good case would be you don't fail over until somebody tells you to, because you're going to wait for the window. But also, if it does fail completely, then obviously you want the other one to take over, even though they didn't explicitly say that, because then they'd be out, right? So we don't want that. But so you almost have like an explicit mode of saying, don't fail over unless there is a true failure, and then you're waiting for some operator to come down and explicitly say to fail. But so it can be as complicated as that, right?
Yeah, so Gerald, for this we need to have some ability to configure it, right? So basically, ability to configure whether it's automatic failover in case second device is allowed or not, right? If we have 3 devices, right, then usually we don't do this because 2 devices are basically doing this, and the third device we are leaving. In 2 devices, this become more complex, so this may be needed. with this kind of automatic stuff, right? So definitely ability to kind of like have visibility to this racing status, right? And ability to configure it, how you want to handle this automatic failover with those different modes. And we should probably document those modes as you, Gerald, mentioned, yeah.
Yeah, a little state machine that we need to be in, kind of, so that you can view what is the true state. And I think waiting for sync can be one state, and then the other state is I couldn't wait. I could fail over it. But you should be able to observe that if that would ever happen. So there needs to be a little state machine.
Yeah, and additional is additional stuff that I want to mention is that we want to have ability to sync the flows, but we don't want you guys to sync the config. So basically, config will be providing on our side. So basically, the device will start up, let's say completely new, right? And we will provision the config. So you guys just need to basically sync the flows, right? We'll provision the config. And this is one of the reasons why we need to manual control, because even if the flows are fully synced, but let's say device got fully rebooted and let's say config got lost, right? We still need to have acknowledgement from control plane that we fully configure the device correctly with all the correct policies which are up to date before allowing to BGP to be fully advertised.
Well, that's another state.
Yeah. Yeah, so config will be synced by config sync is not in scope, and it will be basically synced by control plane, right? So explicit like no goal.
Out of scope for the HA protocol.
Yeah.
So I want to understand a little bit better about let's say automatic failover and manual failover. I don't know about the others, but I didn't really get the difference between those two, and I don't. Before moving forward, I would need to understand what is the trigger for
automatic versus manual.
Yeah.
So basically there is like few modes of operation. So in normal case, basically two devices are online and they are syncing the flows, right? And they are both advertising BGP, right? Either preferably in this active mode when both devices advertise the BGP in the same way without ASN equipment, right? So they both advertise BGP, right? And in, for example, let's say one device dies, which is kind of like basically it dies, right? Then the other device will pick it up and kind of can resume the existing flows, right? And because the device dies and it's kind of emergency situation, then for example, if last, let's say, few flows, hopefully not, but let's say they terminated, they kind of like accidentally may disappear because maybe it's not like perfect and this kind of stuff, right? So this is kind of like automatic failover. And then with this automatic failover, for example, if this failover is because, for example, there is a connectivity flap between, for example, one and the second device, right? But both devices, because we should also discuss network partitioning, right? If both devices, for example, are advertising BGP and they're actually fully healthy, right? The only thing that happened is they were temporarily network partition, which means that they both put advertising BGP, but they just couldn't communicate the sync state between each other, right? Then when this kind of connectivity comes back after network partition, then those devices, because they are already advertising BGP, right? They should be able to kind of establish connectivity back online, because just the basic syncing needs to be reestablished after this was lost, right? And then there is a manual failover case, and the manual failover case is in case, for example, let's say we actually need to service one device, let's say update firmware, and this cannot be updated by SSU and kind of in flight, right? So kind of we need to close one device. Then you will issue that, okay, put this device offline. So basically, explicitly, we need to have ability to issue the command to the device, let's stop advertising the BGP VIP, right? Make sure that all the kind of connections move out of the device, right, in kind of gradual, natural way, right? And we should have some metric to figure out also, are the new connections still coming to the device, where the device like fully shut down regards to all the flows are fully synced, those kind of stuff. And then we will turn off the device, like in a way, okay, now we can service it, right? And it's kind of the manual failover case. Now we can service it, right? Or exchange to different device, and then we bring the new device or reboot this, reprovision the state, say resume pairing, right? It will start basically doing the pairing again. It will start syncing the flows. We'll basically monitor this kind of status, the racing status, and when the status is fully come back online after, for example, servicing, and all the flows are kind of synced, right? We'll confirm on our control plane additional health metrics, including the stuff that we programmed the latest configuration and this kind of stuff, right? And then you will say, okay, everything is fine. All the kind of checkboxes are green. Now advertise BGP again on this device and make this device fully online. So this is the differences between manual failover versus explicit failover, right? Or sometimes we may notice that, let's say, some devices behind some Tor which is misbehaving, right? And we actually need to potentially remove this device and this kind of this manual failover, so only one device will be active, for example, and then bring up different pairing device behind some different Tor. This will be the manual failover.
Yeah, so what I noticed in here that nothing, no input, no operation is done on the device that will take over the flow. Everything is done to the device that either it fails itself or we are putting it down. So we there is no input to the other device that will become active for that flow. Is that true?
That's true from the point of view of the control plane, right? So the control plane will not tell anything more to the other device. The control plane basically will say, okay, shut down this device and like primary device, let's say, and the primary device then using the sync protocol will need to communicate that, like, hey, I'm shutting down, for example. But the question is, like, doesn't need to communicate, right? Because theoretically, once it stops advertising the VIP, right, then basically the sync anyway happened, right? So it just needs to make sure that this device completes the sync. So maybe even the other device doesn't need to know from the other device. It is just basically we just syncing the flow in one direction only, and then at some point basically we'll stop syncing the flow because there's no new connections arriving, right? And then we just disconnect, so the other device may think about the device that goes disconnected. Definitely it makes sense to submit to this like HA protocol some information that the device was gradually shut down instead of basically actual automatic failover because of like a network or those kind of stuff. So the other devices has some internal status, right? But at the same point, I don't envision that the other device will need to do a lot from this point of view.
Right. So I think we agree on the expectation that control plane on the one that is becoming active for the flow doesn't really do anything.
Yeah, the control plane will interact only with one device that you want to shut down, right? So basically issue the shutdown command to the device and expect this device to gradually and correctly shut down by offloading all the flows to the other device, yes. And there will be no control plane operation on the other device.
And okay, and the last question, how do we signal, I'm trying to understand if this is in the scope of the protocol or maybe it is done by other means. How do we signal to the network that we are fine to take over those flows back again when we are coming back up from, let's say, maintenance? It's purely done by starting to advertise BGP.
No. So this is kind of should be similar, like maybe not the same protocol, but like because there is no Paxos or those kind of stuff, right? But basically the device should basically like signal that, hey, device is losing leaving the, for example, the peering establishment. So basically the device will say, hey, I'm basically syncing you the flow because basically in a second I want to, for example, shut down myself, right? And then when the device come back online, right, it will basically reestablish the pairing connectivity with the other device, right? So normally be open the port, open the connection, and then say, okay, I'm just new device that's back online, please send me back the flows, right?
Yes.
And then so this should be inside the HA protocol, right? So the device basically will turn on the device, say this is the pairing, and this should start doing the pairing.
But after we did the resync, how do we signal to the network that now we are okay to?
Yeah, I think this is BGP more signaling where you both have AS prepend from the beginning, but when the other device takes over, it becomes a shorter. It advertises without AS prepend or with less AS prepend, becomes the preferred. But when you go back, you advertise again the same IP prefix with the prepend again. That way you can shift all traffic back and forth through BGP which is what you need to do, because you've said, I want you to now take over. You are synced. You did a perfect sync. You did everything else. Now you need to play with BGP like dynamically to get the equal, or sorry, to get the those flows to migrate back. I think.
Yeah, I think Gerald, we do have an option in BGP. From VM side, Gerald,
but it wouldn't be it wouldn't be between the devices. The HA protocol would be more like the state machine said, I'm going back to this state, and then that affects your BGP advertisements, and then you end up migrating the flows back that way after everything is synced.
So is it fair to say that after resync, moving actual traffic to the new appliance is out of scope of this protocol? It could be by means of BGP or something
I think we need to say how, because it's probably going to key off of the HA state machine. There's got to be a state machine which is controlling this stuff. And when that state hits, then BGP needs to be fired off to advertise, differently. But I think it can't be out of scope. The messaging is out of scope because we already have messaging for that, BGP messaging. But the state machine must indicate when this is supposed to occur so that other software can come in and do the right thing, like re-advertise BGP using BGP prepend in a different way.
Right. And that's why we have...
So we don't define the message, but we have to define a state machine that tells some piece of software to go and do that. Otherwise, a human would have to do it. Right? It needs to key off the state machine.
Yeah, so the state machine and control plane will see the sync status and will say, okay, start advertising BGP, right? And I'm thinking that definitely once the device starts advertising BGP, the device should also communicate to the other pair that, hey, I'm advertising BGP, because maybe this somehow changes the internal sync protocol, this kind of stuff. So I'm not quite sure if basically the sync protocol state machine will somehow rely on information which device is advertising BGP, right? But it may. So I think as part of the protocol, the devices should communicate to each other whether the device is advertising BGP or not. However, whether to advertise BGP or turn it on, turn it off, there should be control also from the control plane perspective.
So Gerald, I have a question on the VM side.
Go ahead.
Yeah, so from the VM side, right, if I want to, after every sync is done from the other peer, like if I want to open up for any new flows from the VM, right, do we have any option? Like when do I, get the flow after the complete sync, right? Do you have any option?
Well, the VM doesn't know. The VM's traffic just flows to where the shortest path is, right? So once it
do we bring it down, path, bring down the port? Back. Okay.
No, because they're in sync. It doesn't know. It doesn't even know there's two devices.
Okay.
The flows from the VM will just magically arrive on the other appliance. It's already synced up. It will process that flow just like the standby or the primary. Either way. So the VM doesn't know this. It has no idea. It's still sending the same channel information it always has. It doesn't actually know where it lands. It doesn't need to know where it lands because everything's in sync.
Yeah, VM should not know anything that happens like that, because like right now, for example, the Tor dies, right? VM doesn't know because Tors are just like somewhere in the middle, right? And the same with this is this forwarding appliance that's like in the middle, and VM shouldn't know. VM basically sends traffic to the VIP. It doesn't care which appliance takes care of the VIP, right? From the point of view of availability, the VIP should be just available, and every single flow should be working, every connection should be working, but the VM should not care which actual appliance handles this.
But how do we make sure that the VM traffic lands on the appliance after the fully synced with the VM?
I mean, BGP handles this, right? Because like the VM gets advertised.
BGP on the network side, isn't it? Or
BGP will be on the primary. Like now you're going back to you went to the secondary, now you're going back to the primary. It will be advertising a BGP with a shorter prepend right now, and so everything will just magically flow back to it. For that BIP.
BGP, when we say BGP, it's for the underlay, correct? Or overlay, we are not really.
Yeah, exactly. Yeah, so they're just sending it to what they think is a card, for example. And that card now is on the other device. It doesn't know that. It just knows it sent it to a BIP. And that BIP used to be on this appliance. It doesn't know that, but it arrived there. And then now it's arriving somewhere else because of that appliance went away. It's still the same BIP. So all its packets through networking, the underlay, will migrate. Its path will just change to the other device. And then when that device comes back online and it re-advertises its BGP with a shorter path, it will magically, all the packets will arrive on that again because it's got a shorter path as far as BGP is concerned, right? So the BIP doesn't change, but the path length changes. The primary is always the shortest length, but if it's not there, then obviously the secondary is the shortest length because it's the only thing being advertised. But once the primary starts re-advertising the shorter length, then everything will migrate back to the primary, or at least the connections that were going to that. Okay. So you don't have to do anything special there. What you need to do is just to make sure, like what Michael was saying, when do you start advertising BGP is a real question. But once you do, it's going to have a shorter path, and therefore everything will migrate to it. So the state machine will probably tell you when to start your BGP advertisements, but when they start, it will always be the shorter path, and everything will flow back.
I think there are timeouts and stuff like that.
Yeah. That's why you need state machines to control all this. There's the intent, and then the state machines need to tell you what state you're in, and then there's I don't know about the timeouts. Which timeouts were you specifically talking about?
The MED, I think we do have timeout control in
BGP. Timeout for what?
The MED when to basically set the first you will set IR med so that that path won't be chosen. Then if you remove that, then the appliance new.
But remember, the whatever was the secondary will continue to process any packet that arrives on it, right? And it will continue to sync that dynamically with the other side till it actually has handed over. It doesn't care. They're both packets could arrive on either one, and they would both forward it.
Right.
Until it's in the state where only one should. But it sounds like lots of good discussion on how these things should work.
Yeah, which brings me to the next thing that I think we need to focus on, because up till now we were only discussing this. So I think the next important step would be to put everything on the paper and have a detailed description, maybe with the diagrams for every flow that that we can think of, and how we from control plane point of view, from data plane point of view, how we see them working before we actually go to defining the protocol.
I think defining the state machine is very important. Like without defining this, without doing that, you're going to be lost because everything will be an exception later on. So I think that we should concentrate on, what are the requirements for the state machine? Michael's already said that we want to have a state machine that doesn't allow the automatic failback until told, but also, if it still fails, then obviously we want it to fail over as a last resort, and all that needs to be decided by a state machine. So I think the requirements should be against like the states that you should be able to support, and if we get that right, then we can start moving on to other things, because like we already discussed, we don't need to define BGP. We just need to define a state that tells the software to initiate a BGP advertisement.
Yes. So, agree.
So if we do it from that way, it will look something very similar to when you see this TCP state machine. There's all these cases, right, of how you open and close things. I think it's the same thing for HA. There'll be all kinds of like intermediate cases that we need to define.
Yeah, so I
And
think to summarize, we want to define the state machine and then express or show how the states will change for any kind of events in the network. So that,
yeah, or
that should be
events and or user provisioning, like what he said, where you actually go down and.
Yeah, okay. I think we have something in the chat. Chris, you had some message?
Yes. Last time, 2 weeks ago, I showed some diagrams that I proposed to put into the document. So it showed the smart switch as well and got some feedback. I mean, you could click on that link if you want to share, or I can. And it shows the diagram. I have a pull request to put these into the main doc. If you want me to share.
So pull request or
I added
which
the
one?
pull request 2 weeks ago, which is in the chat, PR92, and it's adding, it's replacing the old document, which was just a ping. Yeah, if you go to the README, you can just view the README and you'll see the images. Just, I mean, that top document, just do a view file and you'll see. Okay, then you go down to the pretty pictures down below. So I showed these last week, but I didn't have the third appliance C, and down below I added the third switch. And I believe Michael might have said, you know, this TOR C would connect to the T2 tiers. So if I can just get a little clarification, if the group thinks these pictures are helpful, we can merge them into the main document. Just so I don't have these open PRs. If you recall the old document.
Not correctly in this case, and because the HA sync that you mentioned in regards to messages, right? This most likely will not go through T1s, it will go through T2s. So basically the pairing appliances will be farther away, because sometimes the appliances will be in like the other basically paired appliance may not be able to basically fit physically in the data center under the same T1.
Okay.
So basically, in principle, because the original diagram was showing something different. The original diagram was showing two appliances which were basically cross wired to the same T0, and then they were connected to T1s. That's correct, right? But the sync process was not between those kind of appliances. The sync process will be most likely behind the appliance, and maybe we can put it under the same T1, but most likely they will be under different T1, so they will be only connected with T2. So just small changes, I think.
Okay, it would be very helpful if you could just make comments on that PR itself, and then I can adjust the diagram, and then we can look at it one more time. But it'd be nice just to move this along so we don't have PRs floating around. So any comment you want to make, I would really appreciate. I'll tweak the diagram, and then we can look at it one more time.
Yep, I will.
Thank you. Yeah,
add comments to this one. Cool.
Okay, thank you.
But isn't that, Michael, isn't all you want is a little cloud between that one device and the other? Because it can be anywhere. It could be under a tier 3, it could be under a tier 2, it could
That's
be under
correct.
a tier 1. So I think what you need to do is just draw a little cloud there, because we don't know what that, there's no direct line. There could be, but there's no guarantee. So you put a little cloud there, and that indicates that that control channel is going over a network.
Yeah.
It doesn't really matter how big the network. It could be big, could be small, could be direct connect. It's a network. I think that would solve that my concern.
Yeah, that's correct. So it goes through the network. We'll make sure that the network has sufficient latency to kind of handle this very, very fast, and kind of make sure that we could hit the CP. It will not impact basically CPS numbers or latency or bandwidth in some specific way, right? But yeah, it just goes over the network.
Super. And I think the switches above are okay because, it's just a cloth network. So yeah, for the connectivity above, yeah, fine. But it's not a tier 1, 2, 3. It's any club
Okay,
above,
sure.
any network above, right? So that you don't have to change. You just don't call it a tier 1, 2, or 3. Just that's fine.
Got it.
Somewhere.
Okay.
And the cloud, and I think you'd be good because even that third device, you know, you talk to it through a cloud too. Like it's just a network. There's no direct connectivity to that third device. It's just connected to the network.
Okay. Thanks for the clarification.
Would that be okay, Michael?
Yep, definitely. Yeah,
okay,
I know. I just had to basically find a button to unmute. Yeah, this will be okay.
Okay, so then we don't need the PR. You can just make that and then add it to the document.
Well, that's what the PR does. It's just saying, I want to make the following change. So I'm adding it to the document via the PR.
Okay. So you'll do that now? Everybody's
Well,
agreed?
what I'll do is it'd be nice still to have a few comments in there just so I don't forget details, and then I'll update the document, the drawing, and it will still be in the PR, and then we'll say, okay, approved.
Do you have the PR in the window so you know the specific one to go do the comment?
Pardon me?
Do you have it in the comments, the specific PR you want us to comment on?
Yes, yeah, PR 92. It's in my comment right there.
Okay, good.
And we move the PR forward, pull request 92. So if anyone wants to comment, it'd be really helpful. And then that'll be in the record, right? And then I'll tweak it all. Thank you.
Gerald, one quick question. I think when you mentioned about 3 node, initially it was 2 node HA and then we increased it to 3 node. Is the 3 node is what we are attempting for the phase 1 or it's for the future?
3 node is like a perfect example of that. The primary fails, but it's permanently failed. It's dead. It's broken and we need to replace it. Well, you need a third node because we're going to repair to a working device, right? So the third node is important to have there because for that to occur, you have to do a perfect sync. For example, you got to bring it up from nothing. And so there's different requirements when you do that. So the third node is not active. It's you go to that when the primary or the secondary fail physically, like they're damaged. Then we need to bring in this new device.
Okay.
It's not that we're load spreading across 3 devices. It's we need to describe how you get from a broken node, which is going to be taken out, to another working device somewhere. And what does that look like? That's what I think. So.
Okay.
Gerald, a question here. Is this the case where the primary is completely non-functional and so it's really the secondary which is now talking to the spare, or the primary is still functional and it is expected to synchronize with the spare?
Yeah, well, either one, primary or secondary, can fail permanently, right? So we can't say primary. We can say that either the primary or the secondary has permanently failed, and we need to sync to a new device from scratch that was not part of the pairing. That's the requirement.
Yeah, we should assume these 2 devices are active kind of mode, right? So there is not really a concept of primary, secondary underneath, I think, yeah.
Yeah, because they're both active.
The reason I'm asking is
we need to define it because this is actually a very routine thing. Like things fail, so you got to have a mechanism to bring the other one into an active role from scratch without tearing down connection, right? And that was the whole point of perfect sync, to do that.
How is this different from either of the nodes getting completely power recycled? So you have lost all connectivity to it, and it's the same hardware that comes back.
Well, it could be slightly different. We'd have to look at that, but the slightly different could be what its role is, like whether it is primary or secondary or whatever. I'm not sure. It could be that going back is the same as, but the difference is this new device needs to be totally provisioned from scratch. Like the old device could go, like all of those CPUs, for example, could go down, but the provisioning is still there. the whole appliance doesn't need to be reprovisioned. It may be just a software update to the actual DPUs themselves. Whereas a new appliance, it has nothing. It has no knowledge. There's nothing inside of it that knows anything about the service. So that could be just like one example. I think for the most part, they would be the same. But we just need to draw it so that we don't forget that that's the scenario and that we account for it. And we don't, just assume, oh, there's no corner cases. There probably is corner cases. Like when you add a new device, the first thing you have to do is to go and provision it before you do anything.
Yeah, I think we can just clarify that the third node is could be the same node after software upgrade and other cases, but
Yep.
yeah,
I think so. It may turn out to be very similar, but for now, since we don't want to lose that case, let's draw.
Okay.
We can prove that it's not even necessary to show it. Fine, but I'd rather start with it so we go and prove that before we just take it out. Probably that's going to come out of the state machine, and like as we start looking at the state machine more clearly.
Yeah, so since we are 5 minutes over time, I think we can agree that starting next week, we will start working on the state machine. Is everyone fine with that?
I was on mute. I'm fine with it. Everyone else on the call?
yes, yeah.
Yeah.
If somebody wants to come in with a proposed state machine, that would be, even better. But I'm not sure that having nothing and coming into a meeting and say we're going to work on a state machine, how far we would get.
Yeah, I will definitely have some homework done by then, so we can start with something.
Yeah,
I agree that having nothing, it's not the way to discuss it.
Okay, good.
Right.
Sounds good, guys.
I have another meeting as well. Thank you all for coming, and thank you, Marian, for leading this. Everyone participating. You all have a good day.
Yeah, thanks everyone. Bye-bye.
Bye-bye.
Yeah, thank you, Mary, everyone.
Thanks, guys.